Okay, so this video is about deciding when functions are increasing or decreasing algebraically. So you guys should have already watched the video about how to read derivative graphs. And we kind of looked at how when a function is increasing, that the first derivative is positive. When a function is decreasing, his first derivative is negative. So I'm going to go ahead and write that down here just so you guys have it. So if f of x is increasing, then f prime of x is positive. The slope is positive. When f of x is decreasing, we know that f prime of x is negative. So if I want you to determine algebraically the intervals where f of x is increasing or decreasing, the first thing you're going to do is determine what f prime of x is. So in this scenario, f prime of x is 3x squared minus 3x. So the way to kind of approach this is to think about, to go from being positive to negative or negative to positive, you need to pass through 0. So what I do is I take this and I set it equal to 0. And I'm going to go ahead and factor. And I get that x equals 0 and x equals 1 are the two places where f prime of x is equal to 0. So I'm going to go ahead and take these numbers. I'm going to set them up on a number line. So I have 0 and I have 1 on my number line. And then in each region, you're going to kind of pick a number to test. So I'm going to test -1. I'm going to test 0.5. I'm basically just picking one number per region to test. And I don't care about what the value is. I just care what the sign of f prime of x is. So I want to know the sign. So if I plug in -1, 3 times -1 is negative. And then -1 minus 1 is negative. So overall, that sign is positive. So that means in the region from -infinity to 0, f prime of x is positive, so f of x is increasing. If I plug in 0.5, 3 times 0.5 is positive. 0.5 minus 1 is negative. So overall, the sign is negative, which means on the interval from 0 to 1, in this interval, f prime of x is negative. So f of x will be decreasing on that interval. And then when I plug in 2, which is my test point in the last interval, 3 times 2 is positive. 2 minus 1 is positive. So I should say positive. And so overall, the sign of this will be positive. So f of x will be increasing in that last interval. So I'm going to go ahead and write a sentence about that. So f of x is increasing on -infinity to 0, union 1 to infinity. Notice I'm using these points, not the points I tested when I write my intervals. Because, and this is where you have to be very good about writing your reasons, f prime of x is positive on those intervals. And then I will write a second sentence, f of x is decreasing on 0 to 1 because f prime of x is negative on the interval. And that's it for this question. So if I look at this second example, you might want to pause the video here and take a second and do the derivative yourself, but we're going to be looking at what intervals f of x is increasing or decreasing. So the first step again is to find f prime of x. In this case, it's going to be 3x squared plus 6x minus 9. And again, I'm going to set it equal to 0. So the first thing I'm going to do is factor out, my x's look funny there, factor out a 3, so it should be minus 9. So I have 0 equals 3 times x squared plus 2x minus 3. And then I'm going to factor this section, which will be x plus 3, x minus 1. And then I set each factor equal to 0. 3 will never equal 0, so this really doesn't count as a factor. So x will equal negative 3, and x will equal 1. So when I set up my number line over here, I'm going to put negative 3, I'm going to put 1. And then again, I test a number in each interval. I usually write down what the numbers that I'm testing, but you don't really have to. So before negative 3, I'm testing negative 5. In this interval, I'm testing 0, and in this interval, I'm testing 2. So when I plug negative 5 in, I always check it in the factored form. So in this form here. So if I do 3, that's positive. Negative 5 plus 3 is negative. And then negative 5 minus 1 is negative. So overall, the sign of f prime is positive. Positive times negative times negative. So when I plug in 0, 3 is positive. 0 plus 3 is positive, and then 0 minus 1 is negative. So overall, the sign of f prime is negative in that interval. And then when I plug in 2, I should get positive times a positive times a positive. So overall, the sign of f prime is positive in that interval. So again, I'm going to write a concluding statement on negative infinity to negative 3 union 1 to infinity, f is increasing because f prime is positive. On negative 3 to 1, f is decreasing. That was a terrible decreasing. Because f prime is negative. It is not sufficient to just have the number line. You need to have a sentence that explains the work that's in your number line. All right, the last example, I just wanted to do another one that has a different rule involved. So this one is dealing with quotient rules. So you might want to take a second, pause the video, do the quotient rule, and then check and make sure you got the correct derivative. So we're going to set this derivative equal to 0 once we have it. So the quotient rule is low d high minus high d low all over low squared. So low is x plus 3, d high is 1, minus high, so that's x, and then d low is 1, all over low squared. So I have f prime of x equals 3 over x plus 3 squared. All right, so this one is a little bit different because if I set this equal to 0, and I say 0 equals 3 over x plus 3 squared, that's not going to give me any values at all. The numerator is never 0. However, critical values, which are the ones I'm looking for when I set it equal to 0, can also occur when f prime is 0 and also when f prime is undefined. So if I look at this, I can make this undefined. So if the denominator was 0, if x plus 3 squared or just x plus 3 was 0, then this would be undefined. So at x equals negative 3, this function is undefined, but so is the derivative. So that's the only value I have that's a critical value. So again, I can still test the sign of f prime. I'm going to test a number that's below negative 3, so like negative 5 is my test, and I'm going to test a number above like 0. So if I plug negative 5 in, the derivative here will be positive because negative 5 plus 3, when you square it, you get a positive. And when I plug in 0, I also get a positive. So in this scenario, f is increasing on the interval from negative infinity to negative 3, and again from negative 3 to infinity because f prime is positive. Now at negative 3, it is not actually increasing because negative 3 is not even a value on this graph. So just make sure that you are aware of what the domain is as well.